Okay. All right, so here's a little introduction to combination circuits, okay? And this is usually one of my favorite days in the year, but we're sort of missing out, but that's all right. We'll do the best we can. All right, so let's say that we have a circuit that looks like this and has a resistor here, okay, and has a resistor here, all right? We would say this is a circuit that's in parallel because there's two different branches, okay? But what's going to happen if there's a resistor here and another resistor here, okay? Now I can see that this is going to be a parallel circuit because there's more than one branch, but right here is a series circuit because there's only one path through these two resistors. All right, so then this becomes what we call a combination circuit or a combination circuit. It's both series and parallel. Okay, so you have to kind of think about the rules that are going to govern that. Okay, so there's two different ways that a combination circuit can look. That's one of them. All right, and then let me draw another one. Might look like a series, right? It could have like a series circuit like that, but then it has another branch, okay? Right, that's another way that the combination circuit can look. What's wrong with this thing? Why is this frozen? Oops. Okay, if I have to go back, I'm going to be really irritated. Okay, there we go. Okay, so that's the two different ways that those combo circuits can look. Okay, so let's kind of break them down a little bit, and then you're going to try some of the examples. All right. Okay, so the easiest thing to do as usual is sort of to track the voltage changes. So let's say that this is a 10-volt battery. Okay, up here is all going to be 10 volts, and down here is all going to be 0 volts. All right, so this resistor is going to get a 10-volt drop, and this combination of two resistors is going to share that 10 volts. Okay, so it might be 5 and 5 or 7 and 3 or 9 and 1. We don't know. But either way, these two, so this is R1, R2, and R3. So either way, these two voltages are going to have to add up to be 10. Okay, this one is going to be 10, and the total is going to be 10. Okay, all right. This little tiny piece of the circuit right here is in series, okay? So if I wanted to know the resistance of this branch, I can just add them up because they're in series. I cannot add this one to it, right? I can't add R1 to it because that part's not in series, but R2 and R3 are both in series, so I can add up their resistances, okay? Also, what's the other thing we know about series? Okay, that the current is the same, right? So the current in I2 has to be the current for I3, right? Because down this path, once the charges come through here, right, they're going to split. Some are going to go down the first path. Some are going to go down the second path. But look, there's nowhere else to go. So the current through 2 and 3 has to be the same, right? There's no way to split anywhere else. So those currents have to be the same. Okay, and then whatever that current is plus this current is going to be the total for the circuit. Okay, it's going to make a lot more sense once we do a couple of examples. Okay, so just don't panic, but just I want you to see it. Okay, all right, the other kind of circuit that it can look like is this. So let's again go with, our 10 volts. Okay, let's follow this 0 all the way around, and let's follow this 10 to here. Okay, so now look, we don't know the voltage drop here because we don't know the voltage in here. Okay, so we would have to know some kind of information, right? We'd have to be able to find it, all right? So let's say this is R1 again. Let's say R2, R3. I know the total current coming through the battery. Like say it's like 5 amps or something, right? 5 amps. That's also going to be the current through resistor 1 because it's on that same path with the battery. Okay, all of this path here, there's no splits. So this is all going to be 5 amps. Okay, so if that's 5 amps here, right, we'd be able to use this to find out what the what the voltage drop is across this one. Okay, so let's say that this is, hope I don't mess this up. Let's say that this is just a 1 ohm resistor. Okay, so if that's a 1 ohm resistor and 5 amps of current, this is going to be a 5 volt drop here. Okay, right? So if this is a 5 volt drop, that's going to put us at 5 here. That's kind of a bad number because they're all going to be 5, but you'll get the idea. Okay, and now each of these, do you see they're going to have the same drop because they're in parallel, right? They're both having that drop from 5 to 0. All right, in this case, they're all 5, which is, you know, whatever, but whatever. Okay, all right, as far as the current, right, the current, this 5 amps of current, as it comes in here, is going to split, right? So 5 amps, or the total, is going to be 2 and 3 added together, because that 5 amps is going to have to split over both paths. Okay? All right, and then to find the total resistance, you're probably mostly stuck at using this, right? Because otherwise it's kind of complicated, but, you know, doable. All right, okay, so that's quick overview, but let's try a couple problems on the next couple slides, and then I think you'll get it better.